Hi there and welcome to this step-by-step build video for the 10-minute workshop DIY rail hinge. I made this hinge specifically to scratch a few itches that I had with the existing commercial rail hinges from Benchdogs, from Dashboard and the Festool OEM hinge, and as fun as they are, as I said on the public YouTube video, my needs are slightly different now because of how I use my MFT as a static bench in the workshop. If you haven't watched it already, then I'd recommend you take a look at that YouTube video. There's a link on the plans. The rail hinge comes in two parts, the hinge itself and the front rail support. The plans show all 12 of the components needed, both as an overview and as a full-size drawing that you can print out and use to reference the drilling positions if you choose, or just to work out the most economical way to get the hinge cut from the material that you have available. If you're starting with a clean, fresh sheet of board, then you'll get all the 12mm parts comfortably cut from a piece roughly 600 by 500mm, perhaps a little bit less if you squeeze them together a little bit tighter. As I said, there are 12 parts in total, with 4 of these parts, the body, the spacer battens and the riser, common between the hinge and the front support, with the other 4, the hinge pivots, the rail platform and the capping piece, making up the rest of the hinge. The actual dimensions of the hinge are very much up to you. I've made mine to suit my bench and to provide full width rail support for the Festool and Makita pattern rails that I use most, but plans are always a starting point, so adapt them to suit your needs or your tools as you see fit. I've cut out all the components, and if you don't want the swoopy curved wings on the body, then everything can easily be done with just a track saw and a little bit of care. Otherwise, just use whatever you're most comfortable with. The hinge pivots are quite small parts, and if you have a small bandsaw, then that's a good tool to use. They also need to be drilled quite carefully, and I'd recommend sticking them together with double-sided tape and drilling through them both on a drill press or pillar drill, as any discrepancy between them may affect the hinge geometry or rail squareness. I've used a 5mm bit in the corner for the steel dowel pins and a 3mm bit on the edge for the wood screws to hold the pivots onto the hinge riser. The front and rear risers need to be carefully cut so that both edges are parallel, as these will slide between the batten spacers and you don't want them getting tight or loose as they move. It's best to get all the drilling and machining done before you start the assembly, so let's put the front rail support together first. As I said, we have the components cut already, so we can mark and drill out the 8mm through holes in the body that will take the T-bolts to fix it to the T-track in your bench. I've also drilled an extra 8mm hole on the inside face of the right hand side wing in line with the fixing hole, but a little further over closer to the edge, and I'll be fitting a cut down dowel into that hole. We need a slot in the front riser for the M8 bolt that tightens it up, and I'd suggest an 8.5 or 9mm slot for this, just to give a little bit of wiggle room. If you have a plunge router, then that's a good tool for this job, but you can also drill a couple of holes at either end and cut out the waste with a saw. I need a corresponding 8mm hole in the body to take the M8 bolt, and I've cut a recess in the back for the bolt head to sit flush. Again, use a router if you've got one, or just drill out a counterboard deep enough for the head of the bolt. A dab of glue or maybe some double-sided tape should help to keep it in place. With that done, I can line up the riser and, making sure it stays true as it moves, fix on the first batten and then the second. I've just pinned these on. If you want to add glue as well, or instead, then I'd suggest keeping it to the outer edge just in case. Remember, the riser needs to slide smoothly, not too loose and not too tight. I tried the old trick of putting a sheet of paper between the riser and the batten before fixing it down, but I found that was a little bit too loose for my liking. I'll leave that up to you. And finally, I'll push fit that 8mm dowel in close to the edge, and that's pretty much the front rail support done for now. The body of the hinge goes together in pretty much the same way, holes drilled in the wings to match the rear T-track, but with a 6mm capping piece covering the riser to make a nice friction fit, and shaped to provide as much support as possible for the riser. I sanded the bottom outer face of the hinge riser and the top inside face of the capping piece just a little bit to make them easier to mate together. Remember, you'll be doing this whilst reaching across the bench, so no need to make life difficult for ourselves. The hinge riser is a nice friction fit, but I also wanted to be able to lock the hinge off at a set height for common thicknesses, and I've done this with a simple set of holes drilled into the front face of the riser and a pin that fits in those holes and bears against the hinge body. I'm using a 5mm clevis pin with a head for this. You can use whatever you like, just remember that the positions marked will need to be changed slightly if you use something different, as the measurements are referenced off the bottom of the holes, not the centre. The 5mm holes need to be almost, but not quite, through the hinge riser, and I've drilled holes for 6, 12, 18 and 24mm thicknesses. An easy way to do this is to align the riser against a fence at the lower position and then add in bits of scrap against the fence, first 6, then 12mm, then 18mm, etc., to step these holes out, shifting the riser sideways slightly to prevent them clashing. Now, because I'm using a pin with a head, I've used my track saw to cut a tiny rebate into the hinge body to accommodate the head and to allow the pin to sit flush. The hinged riser is notched on each side to take the pivots, and I'd recommend working off the actual material that you have when marking this out, as thicknesses do vary. Each pivot overhangs the end of the riser by a little more than the thickness of the rail platform, and once marked these notches can be cut away. Again, a small bandsaw is ideal for this, but I've also done this with a handsaw and a little bit of cleaning up with a chisel. With that done, the pivots can be screwed into the notches. I'm using a 3mm pilot hole and 3.5 by 30mm wood screws for this, but feel free to use whatever you think is best. And remember that the hinge pivots need to face the rear of the hinge riser. That's the face we've just sanded. The rail platform needs to be drilled out for the M6 machine screws that attach to a rail bar that secures the guide rail in place. If you're using countersunk screws, then the actual drilling positions can be moved further back on the platform if you prefer. If you're using regular machine screws with a head, then the head is best to be forward of the riser, so the positions marked on the plans will probably be best. These positions work for Festool and Makita pattern rails, so also the many clones of those rails like Urbauer, Evolution, Titan, Triton and so on that have a common location for the under rib T-slot. As always though, it's worth checking with your rails before drilling those holes. If you're using DeWalt rails, then there's an alternative position marked for the fixing screws, and if you're on Bosch or Mafel rails, then the actual fixing positions can be the same as the Festool, but I'm afraid you're on your own for getting a bar to fit that much smaller T-slot for those rails. I know Ralph at Bench Dogs makes a T-bolt to fit, but they're much shorter than you'd need for the 12mm thick hinge platform like this. I am looking at getting a T-bar made for the Mafel or Bosch rails. Let me know if that would be of any interest, as it will very much depend on demand whether that can happen or not. The Bosch Mafel rails are also narrower than the Festool rails, so you could actually reduce the width of the whole hinge to suit those rails if you preferred. Again, the fixing holes on the rail platform need to be drilled precisely, absolutely parallel, in line with the edge, so a drill press with a fence is a good option. As I said, I'm using countersunk machine screws, so the underside of these holes need to be countersunk to match the heads, and then we can fix it to the riser. I've got the riser clamped on a piece of scrap to represent the hinge body, and I'm using a piece of abrasive as a spacer just to give a little bit of distance between the rail platform and the riser. The top of the platform should be flush with the top of the pivots, and keeping the platform clamped nice and square, I can drill through the pivot with the same 5mm bit directly into the edge of the platform. Then I'm doing it again with a bit of tape added to the drill to act as a depth guide. With both sides drilled and a little bit of cleaning up, I can push in the 5mm steel dowel pins, making them flush with the face of the pivots. If you liked, you could sink them in a little bit deeper and cover the holes with a wooden dowel, but I'll leave that up to you. With the rail platform pivoting nicely, we can add the bar that fixes to the rail. I'm using a 3D printed one from friend of the channel Stu Parker, link on the plans, along with all the other hardware used. And this 3D printed version is the same dimensions as the Festool OEM spare part, just a little bit cheaper and much faster to ship. But you could also make your own from a piece of plywood, or adapt a rail joining bar, or make one from some flat bar if you have some metalworking skills. The rail fits onto the bar and the whole riser assembly fits into the holster of the body. And with the body attached to the MFT using T-bolts and knobs, we can square up the rail against the column of holes in the usual way and lock off the hinge body. With the rail held square, I can line up the front rail support, mark the position of the under rail T-slot, then drill out an 8mm hole for the locating dowel. An 8mm dowel will be a little bit loose in the rail T-slot, but a couple of turns of tape will sort that out and is easily replaced if and when it wears. Obviously, if you're using a different rail, you may need to change that dowel size to suit. With the rail square and the front and rear supports locked off, I can slide a stop, just a piece of 6mm plywood with a dry fitted grub screw, up against the dowel we just fitted in the front body and lock that off. Now if we ever need to remove the front support, we can get it back into position without needing to re-square the rail. And that's pretty much all there is to it. In use, the hinge can easily be self-adjusted to different thicknesses of material, or you can lock it off at a set depth. The whole rail hinge riser assembly can be removed if it ever needs attention, like replacing a splinter guard or changing to a longer rail if, like me, you've got a front extension to your MFT bench. And all of these controls are accessible from the front. That's it for this build though. Thanks so much for picking up the plans and for helping support the channel. And if you make the hinge from these plans and share photos on Instagram, be sure to tag me in at 10 Minute Workshop. I'll see you in the next one.